Alright guys, in this video we are going to review some major concepts from Outcome 1. So the first thing that we talked about in Outcome 1 was all about data. When you're looking at data, we want to start with identifying the W's. So this is the who, what, when, where, why, and how of our scenario. I doubt there's going to be a question on the AP exam that asks you to identify these W's, but this can be very, very important when you're trying to figure out what kind of hypothesis test to run or what type of confidence interval to make. Okay, the next thing we looked at was quantitative versus categorical variables. Remember that quantitative data is numerical values, so something that you can find the average of. Categorical are categories or names, you cannot find the average. Okay, so based on this little chart here, we can go through and list whether things are quantitative. I'm just going to put a Q by those, or categorical. I'll put a C. So age would definitely be quantitative. That is something that we could find the average of. Your gender would be categorical. The answer to the question, are you an only child? That would be yes or no, so that's also categorical. Height is quantitative. Weight is quantitative. Credit hours is quantitative. GPA is quantitative, but your major is categorical. Okay, we also talked about discrete and continuous variables. Remember that discrete variables are something that you can count. So for example, I could list shoe size for an example. So shoe size, I could have 6, 6.5, I'm sorry, 6, 6.5, I could have 7, 7.5. This is something that is countable. I can list out my discrete variables. Okay, continuous variables are not countable. Instead of counting, they are measured. Okay, for example, if I'm looking at height, I could say that somebody is 60 inches. I could say somebody is 60.1 inches. I could be very specific and say they're 60.1, 2, 3, 4, 5 inches. And there's really no stopping point there. I could just continue this forever. There's no way that I can make a list. Okay, in Chapter 3, we talked about how to display and summarize categorical variables. So there's several different types of graphs. You could make a bar chart. Remember that a bar chart is going to have your different categories listed horizontally. So let's say I was just looking at favorite color. I would have blue. I would have a bar for blue. I would have red. I would have a bar for red. And I could just keep going here. So let's say this is green. I have a bar for green. Vertically, this would be the frequency or number of people that fall into each category. Okay, with a bar graph or a bar chart, your bars should not be touching one another. The big difference between a bar chart and a histogram is that a bar chart looks at categorical variables. So all of these here should be categorical. Okay, another way to summarize categorical variables is to make a pie chart. Remember that when you're making a pie chart, there should be no overlap between categories. So I could make a pie chart here for your favorite color, where I would have, I'm just literally going to make this up, but here I would have blue, green, and red. But I could not make a pie chart for what classes you're taking, because people could be taking a math class and an English class at the same time. Okay, with contingency tables, so contingency tables are just something where they list several sets of variables. So maybe I'm going to look at favorite color going this way, so I have red and blue. But then I'm also going to look at your grade. So I'll say freshmen and juniors. I might have 4, 5, 2, and 1. Okay, with contingency tables, we learned about conditional versus marginal distributions. So for conditional distributions, we would ask, what's the probability of picking a freshman who likes red? So conditional probabilities would fall into just one individual cell. Marginal distributions are going to look at totals for a specific variable. So you might list the marginal distribution for red and for blue. Well, red I would have 9 out of the total, blue I would have 3 out of that total. And another way to graph categorical variables is to look at segmented bar charts. Segmented bar charts are good for when you're given counts or percentages are given for a few groups. So instead of looking at a contingency table like this, I might make a little segmented bar chart where I might have freshmen in one, and I would just look at this probably as percent here. So I would look at my freshmen. I have 6 freshmen there. I'm going to start with finding the percent that like red. So I would type in, holy cow, you cannot see that. I don't know what's up with my camera right now. Hey, trying to figure out my camera, can't figure it out, so we're just going to roll with this kind of weird exposure situation. I'm looking at freshmen. I wanted to find out what percent of them like red, so I would type in 4 out of the total, which is 6, gives me 66 or 67%. So I would go here and just, hopefully you would have a scale, but I'm just going to go to 67%, and I'm going to make blue stripes. Or I'm sorry, that would be red. Then hopefully my other one, 2 out of 6 is 33%. I could then do the same thing here for juniors. So again, I'm going to start with the red. So that's 5 out of the total, which is 6. Gives me 83, so a little bit higher here. Remember, with those segmented bar charts, you do want to make sure that you include a key. So I would need to show that these little stripes are representing liking the color red, and blank would be liking the color blue. Okay, when we are describing this categorical variables, you do want to make sure that you simply talk about your interesting findings. So do not use socks, which we haven't talked about yet, but all you're going to do is talk about what's interesting. So in this, I would say, it's interesting that more juniors like the color red proportionally than freshmen. Something like that, not talking about the shape or the spread. There's no shape or spread for categorical variables. You're just looking at what's, quote, interesting.